Hi guys, today's notes are on 9.7a using Trig identities. We actually went over these in class, but I'm going to record the video just in case someone needed a little bit of reference. So I'm going to start at the beginning. And please remember that when an angle theta is in standard position with its terminal side intersecting at x comma y, then we can think of x as cosine of theta, and then y can be sine of theta. Right, so this is just another way to think of things. Well, if we have x and y, let's go back to x and y, centered at the origin, using Pythagorean theorem, we can say that x squared plus y squared equals to 1 squared, which we don't need to write in. Okay. So this leads us to our first trig identity using substitution. So I can say that x squared is cosine squared. Oh, sorry, it should be theta, just to keep x's and thetas separate, plus y is sine equals sine squared theta equal to 1. Okay. Just make sure you know that cosine squared theta is the same as cosine theta squared. It's just that we write it this first way because we don't have to write parentheses then. It does not equal to cosine theta squared because you'd have to do that first. Okay? So just know that this means it's cosine theta times cosine theta plus sine theta equals to 1. And this equation is true for any value theta. A trig equation that is true for all values of the variable for which both sides of the equation are defined is called a trig identity. So let's take a look at some of the trig identities that we've actually used without calling them trig identities yet. So these are the ones we've used. I do explain where they all come from in a separate video that I suggest that you take a look at if you don't know where these trig identities come from. Okay, it's not actually this much that you need to memorize. In pre-calc, you'll need to memorize all of them. So knowing how they're related and why they happen, it might help you memorize things later. Okay, so we are going to use these on the next page. But let's talk about evaluating trig values first. Okay, so this first example says that given cosine theta is equal to 1 over 6, and we know that theta is between 0 and pi over 2, find the values of the other 5 trig functions of theta. Okay, so the first thing I want to do is establish that this is actually really important information here, 0 to pi over 2, because cosine being 1 over 6 means that you have, like, this distance is 1 over 6, right? But we don't know if our angle is up here or down here, or our point, I should say, right? Because both of them have an x value of 1 over 6. However, right here it tells you that it's between 0 and pi over 2. Here's pi, right? And 3 pi over 2. And so that means this point is off the table, and this is the one we want. Does that make sense? And so we're now looking at this triangle here. We know that the radius is 1, but we don't know our y value. So we know that we have x squared plus y squared equals to 1. Okay, that's the same as cosine squared theta plus sine squared theta equal to 1. So I can plug in cosine as 1 over 6. I'm solving for sine squared theta and equal to 1. So I'm going to square this. This will be 1 over 36 plus sine squared theta equal to 1. I'm going to subtract by 136 on both sides. So it'll be 35 over 36, right? Because I have 36 over 36 here. Okay, so now to get sine theta, I'm going to square root both sides, right? And when we square root both sides, there's always a plus or minus root 35 over 6. And so the thing is, we have to decide for the first time ever if we're talking about positive or negative value. And in order to do that, you need to know which quadrant, this was quadrant 1, which quadrant you're in, right? Because this is our y value. So we need to know that our y value here is positive because it's going up. So I'm going to write quadrant 1, y is positive. So we have positive root 35 over 6 is what we want for sine. So let's write it over here. Okay. Cosine theta we're given is 1 over 6. Now that means I can take the reciprocal functions of these, right? Cosecant theta is 6 over root 35, which is 6 root 35 over 35. You can't simplify that fraction, so we're done. So first one, second one, third one. Secant theta is reciprocal of 1/6, which is just 6. And then we have tangent. Tangent theta, if you guys remember coming up here, is the same as y over x or sine over cosine. So that means I'm going to take root 35 over 6 all over 1 over 6. We know that if the denominators are the same, we can ignore them or cancel them out by multiplying by 6 over 6. So this is root 35. I'm going to take that root 35 and take the reciprocal to get cotangent. So that means I have root 35 over 35. Okay. So it's still similar to what we did before. It's just that now we have to decide if the values are positive or negative. Let's keep going. I'm going to have you guys try B, okay, and C. So this is your U try. Please pause the video here, and I'll show you the answer key in just a moment. But please keep in mind that we are looking at quadrant 3, and so I would strongly suggest that you draw your point value in quadrant 3 and recognize that you should have a negative x and a negative y, which means both sine and cosine should be negative. Okay. So once you've done that, here's the answer key. Okay, check real quick to see if you've got the right or the same numbers. Most importantly, though, check your signs. Remember that sine and cosine are both negative, which means cosecant and secant are both negative. But a negative divided by a negative is a positive, so tangent and cotangent are positive values. Okay. So let's move on when you're ready. Pause the video if you still need a moment. If you want to skip C, I mean it is really exactly the same just with sine, so I'm okay if you skip C. So let's do example 2, and I'm going to actually put a box here. I need space for 4 lines of work. Okay, so our next example is on simplifying trig expressions. And so what we're going to be given is a bunch of trig expressions with sine, cosine, tangent, secant, cosecant, and cotangent. And what we want to do is simplify them to make them as simple as possible. Okay, so make it into something easier. So what we're going to do is follow 4 steps. And this is what I suggest. The first thing you should look for is a Pythagorean identity. Now, a Pythagorean identity, you're going to see a 1 in there. You're going to see a plus or a minus, and then you're going to see something squared. Okay, and how do I know this? Because if I look, if I look over here, every single Pythagorean identity has squareds, right, and a 1. Now, I say plus or minus because these are positive, but if I subtract sine squared on both sides, then it becomes a negative. Okay? The other thing you want to look for is the cofunction identities. Now, the cofunction identity, what you're going to look for is pi over 2. Okay? Because if you look at your cofunction identities here, every single one has a pi over 2 minus something. I should say pi over 2 minus. Okay. So let's take a look and just start this process. Do you see how here tangent of tangent of pi over 2 minus theta, I can simplify that by rewriting that, and let's check, this is what you're going to do today, we're going to check it, and that equals to cotangent theta. So I'm going to rewrite this as cotangent theta. I'll keep sine theta. Let me flip my colors. I'll do my changes in red and my unchanged in blue. Okay. So what I did was I used a cofunction identity right here to make that change. Okay, so the next thing is we don't have a Pythagorean identity because there's no squareds and no ones. The next step that you want to check for is if you can change everything to sine or cosine and or cosine. So now we know, and that's using the first 5. This is the reciprocal slash tangent and cotangent identities. So we're going to come here and look. Well, I know cotangent is cosine over sine, so I can use the cotangent identity and further change this to cosine over sine. This sine theta still stays the same here. Okay. Step 3, I'm going to skip. We're going to check it, but we can't use this one. This is only if you can factor out common factors. You're going to need a something plus or minus something for this, okay, which we don't have, but you see how here we have it, right? So you want the same thing minus the same thing. And then the last step is to simplify, which means you're going to multiply or divide to cancel out. Okay, so let's take a look. So right now, what we can do is we can cross out sine on top and sine on the bottom, simplify, and our final answer after that is just cosine theta. Okay? Which means that tangent of pi over 2 minus theta times sine theta, which looks really complicated, is just cosine theta. They are the same thing. Okay? All that work to prove that they're the same thing. So let's do another one. B. This one, we don't have a 1 in there, so that's a signal right away. There's no Pythagorean identity. There's no cofunction identity because there's no pi over 2, so we're going to check step 2. Well, everything's already in terms of sines and cosines, so we are done with step 2. Step 3 says to factor out common factors. Do you see how they both have a cosine and cosine? That means I can divide both terms by cosine and cosine, like I can factor it out. Okay, so that means I'll have cosine theta, and then I'll have parentheses 1 minus, right, because cosine divided by cosine is 1. And then cosine divided by cosine is another 1, but sine squared theta stays. Okay? So what we did here was factor out cosine theta. Well, every step, you're going to go back through steps 1 through 4 and see if you can do any of those again, right? So now we're going to go here and we're going to say, can we use a Pythagorean identity? Look, there's a 1 minus and there's something squared. So this is perfect. We're going to go check for our Pythagorean identities. I see sine and 1, so I know I'm going to use this one. And we do need to make sure it works because sometimes they trick you and it doesn't. So in this case, they have sine and 1 on the same side, so I need to subtract sine squared and subtract sine squared, which means then, once these cancel out, that cosine squared theta is 1 minus sine squared theta. So I can replace 1 minus sine squared theta with cosine squared theta. Okay, I'm going to bring this cosine down. And this was called our Pythagorean identity. Okay, so let's do a quick check. We have no more 1s and no more, well, we have squared, but no more 1 plus something, or 1 minus. We've already changed everything to cosines. We've factored things out, and we have only 1 term left, right? So that's perfect. And then now we need to simplify, which means to either multiply or divide. So our final step is just to multiply. There's 1 cosine here, 2 here, for a total of cosine cubed theta. You don't have to write this part up here. I'm just showing you guys that this is what it equals. Okay? So I'm going to write here multiply or simplify. Let's do our last 2 examples. It's the same idea. It's just more, the more you guys see, the easier it will get for you. Okay? So first things first, no 1s, no squares, no pi over 2s. Everything is not changed to sines and cosines, so let's do that. Okay, so secant we can change, tangent we can change, and secant we can change, I guess. Oh, maybe before we do that, I can also factor out a secant. Okay, so 3 and 2 are sort of, you can do them at the same time or do one in front of the other. I'm going to factor out secant and secant. Okay, so I'll have secant theta times, when I factor this out, I'll have tangent squared theta plus 1. And so what I did was factor out secant. Okay. I like to do that first. Now I can change the sine and cosine. So secant is 1 over cosine theta. Oh, nope, I should go in order. Sorry about that, guys. We can tackle that first. Tangent squared theta. It is always easier to get rid of the 1s and the squareds first before you change the sine and cosine. Okay, so if you can make it as simple as possible before you change the sine cosine, then your life is easier. So I probably should have switched step 2 and step 3. Okay, so then we have Pythagorean identity with tangent. So let's go look for tangent, and we see 1 plus tangent squared, and we have tangent plus 1, same thing, is secant squared theta. Oops, sorry. Secant squared theta here. And then we have our original. Okay. And so this, what did we do? This was a Pythagorean identity. I'm going to multiply these first because it's actually pretty simple already. Secant cubed theta. You could argue that you could write it as 1 over cosine cubed theta, but which one looks simpler to you? Right? So sometimes it's not necessary to change the cosine if it's already very simple. I'd stick with this one and just simplify here. Wouldn't mark you off if you wrote it like that, but definitely secant cubed is much more like streamlined. Okay, the last one, or this one, sorry, there's 2 more that you guys can try also. But this last one, you guys can see that there is a 1 plus and a 1 minus, but there's no squared. And there's no pi over 2, we've already changed it, there's no common factors to factor out, and there's nothing we can do to simplify. So in this case, the kind of simplifying we need to do is actually FOIL. Okay. And what happens when you do this is you get 1 plus, 1 times 1 is 1, plus cosine x minus cosine x, and then negative cosine times positive cosine is negative cosine squared x. And you guys see how like these two cancel out? And so what we're left with is 1 minus cosine squared x. Okay, so FOIL. And so what we have now is is going to become sine squared theta, not theta, x this time, right? And for that we use the Pythagorean identity. And we're done. Sorry, I should have written that one in blue. And that's it. Okay, so if you want to try these, take a moment and try. I won't show all my work, but I'll give you what your final answer should be. Definitely practice more in class as well, if you're feeling a little shaky and you want to just wait. But I'll give you the answer. It just both became 1. I think this one's pretty straightforward because you just have to change everything to sine and cosine. We'll practice more in class. Hopefully this made sense.